So friends, welcome to my YouTube channel Spiral Learning. Today our topic of discussion is equations of motion, and the topic is taken from CBSE Class-IX syllabus, and the book which is choose for the topic is NCERT textbook, and the chapter is chapter 8. The equations of motion are: first equation is v equal to u plus at. Second equation is s equal to ut plus half of at square. Third equation is v square equal to u square plus twice as, where u equal to initial velocity, v equal to final velocity, s equal to distance covered by the moving body, a equal to uniform acceleration, and t equal to time taken by the body during the motion. So let's start to establish the equation one by one. So the first equation is v equal to u plus at. So for the establishment of this equation, we will start from the definition of acceleration. So we consider a body is moving along a straight line. It's a straight line motion. So we are considering a body which is moving in a straight line. Suppose the initial point is A and the final point is B. So it starts from the A and finish at the point B. So at initial point the velocity is u, which is initial velocity, and the final point the velocity is v, that is the final velocity. At A initial time is 0 and at B the final time is t. So by the definition of acceleration we can write, by the definition of acceleration we can write acceleration is symbolized by small a. Acceleration equal to change in velocity divided by time taken. Now the change is measured from final velocity minus initial velocity. Final velocity minus initial velocity. Initial velocity divided by time taken. Time taken, that is also final minus initial time. So from the diagram we observe that the final velocity is v and the initial velocity is u. So in place of final velocity we are putting v, and in initial velocity we are putting u. So in left side we are writing a as a symbol of acceleration, and in the diagram we observe that the final time is t and the initial time is 0. So final time is t, and in place of initial time we are writing 0. So a equal to v minus u divided by t. So after cross multiplication we will cross multiply this and this, then at equal to v minus u. Now we are taking u in left side, so the negative sign of u becomes positive. So at plus u equal to v. So finally we reach at the equation v equal to u plus at. So this is the final form of this equation. This is the algebraic establishment. We are using algebra for the establishment of this equation, where v equal to final velocity, u equal to initial velocity, and a is uniform acceleration. Okay, so you should keep in mind that the body is moving with an acceleration a, and a is uniform acceleration. Uniform acceleration. Okay, so now the next one, s equal to ut plus half of at square. So for the derivation of this equation, for the establishment of this equation, let us consider a simple diagram. A body is traveling from A to B and then C. From A to B, the velocity of the body is u, it is the initial velocity, and from B to C, the velocity of the body is v, and the time taken is t second. Now, as we know, the acceleration, uniform acceleration is a. That is, with uniform acceleration, the body covers the total distance, that is from A to B, then B to C. Okay, and the total distance from A to C, suppose, is s. So this is the simple diagram. So here we observe that the body covers two distance in two velocities. That is the first velocity and this is the second velocity. So the total distance is covered within average velocity, and suppose the average velocity, let the average velocity of the body during the motion be a, during the motion be v avg. Therefore v avg equal to u plus v divided by 2. This formula is possible, or this formula is written since the case is uniform acceleration. If the body are not moving in uniform acceleration, then this equation is not possible. We are considering this equation of average velocity, since the body is moving in uniform velocity. Now distance covered by the body in time interval of t second is s. Therefore s equal to v avg, that is average velocity, into time. Okay, but in equation 1, here is the equation 1, we see that the average velocity is u plus v divided by 2 and t is multiplied with it. Now u, and in place of v we can write u plus at following the first equation that we established previously. So in place of v we are using u plus at from our previous knowledge. So this is 2u plus at, so it's partial division, then it's multiplied by t. So here both of them will be cancelled because the numerator and the denominator are same, so they cancel each other. So in bracket we have u plus half of at and multiplied by t. So after multiplication it becomes ut plus half of a t square. So this is the final form of our equation, and in this way we established the equation s equal to ut plus half of at square. This is a very important equation which is important for solving the numericals also. So now the last one, that is v equal to u plus at. Here v equal to final velocity, u is initial velocity, a acceleration, and s is distance covered by the body. So from first equation, from equation 1, we have v equal to u plus at. Okay, so this is our first equation. So now we are squaring both sides of the equation, then it's become v square, it's u plus at its whole square, v square, then u square plus s square t square plus twice ab. In place of a we are putting u, in place of b we are putting at. That is, we are using a plus b whole square formula, that is a square plus b square plus twice ab. Here a equal to u, b equal to at. Okay, now v square equal to u square. We see that a is common in both the equation, so we are interested to take common a and 2 also. For taking 2 we should multiply this way, 2 into half, so we can cancel out 2 with half, so it becomes same, so s square t square. Now we can easily take common 2 and a, 2a, here ut will remain, and here half a will take common and half will remain, half a t square. So I think this is known to us. What is this? This is s, the second equation. From second equation we have s equal to ut plus half of a t square. So third equation is basically established with the help of first equation and second equation. This is the third equation, v square equal to u square plus 2as. So both the equations are very important for the establishment and also for the examination perspectives, and these are very helpful for solving the numericals related to the chapter. Okay, now it's almost completed. So thank you for watching the video. In the next video I'll try to solve some numericals related to this chapter. Thank you once again for watching the video.